Hello everybody, we're looking at lesson 27, which is the beginning of nomenclature. As it says here, nomenclature is just a system of naming. So we're going to look at two basic types of compounds today. We're going to look at ionic, so binary covalent and binary ionic. So with binary covalent, bi just means two. So this is when there's two elements bonded together by a covalent bond. And after we do the binary covalent, we'll be looking at binary ionic, and that's all we will do for today. So there's just a set of rules for each, and you just pretty much apply them every time. So first off, for covalent compounds, I should remind you that a covalent compound is what you get when you have a nonmetal bonded to a nonmetal. So what's going to happen for this is you're going to have both compounds have a negative charge. So because they both have a negative charge, they don't balance out. So because of that, you need, instead of knowing how many of each you have due to them balancing, you need to use this to figure it out. So we have the Greek prefix from 1 through 10, which is mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and then deca. So when you do this, one important detail is that you only need to say mono or say there's one if it's for the second element. If there's only one of the first element, you'll just go ahead and name it without saying mono, and we assume that means one. So, like for example, right here, well, it's ionic. So, like right here, when it's carbon and then oxygen, you don't need to say monocarbon. You just say plain carbon. And we assume you mean that there's only one of them. And then what you'll do is you'll typically say the least electronegative first and then the more electronegative second. So what that means is it typically will go from left to right on the periodic table. And then an important detail is that you take the last element and you change the ending of it to an "ide." That's kind of how you say, I'm done describing this element. That way, if you say, like carbon monoxide, carbon dioxide, I don't think that's just one massive element. I know that you're talking about carbon monoxide. I hear the "ide," that's one compound. And then you say carbon sulfide. Now I know you're talking about a whole new element and you're ending it with that "ide." So "ide" is what you change the ending to on the last element. So here's how we would name these. Okay, remember, there's only one carbon. So you'd think we need to say mono, but you only use mono for the second element. So for this one, we would say carbon, and then we're going to do oxygen. But you don't just call it carbon oxygen. You'll call it carbon. How many oxygens are there? Only one. So carbon mono, and then it's oxygen. You don't say carbon mono oxygen because this detail, you change the ending to "ide." So carbon monoxide. When we say it fast, we say carbon monoxide. Let's go here. Monocarbon, but you don't say mono for the first. So just carbon. And then now how many oxygens do we have? We have two. So we'll call it carbon dioxide. Carbon dioxide. Okay? You need to be able to go forward and backward. You need to be able to look at it and come up with the name, or see the name and write the formula. And then with that, we move on to ionic. Now with ionic, we're looking at something from the left of the periodic table and something from the right of the periodic table, a metal and a non-metal. And so what's going to happen, one of them will be positive and one will be negative. So for ionic, this kind of confuses people. We don't use these for ionic. This is only for covalent. So with ionic, you don't say tetra, penta, hexa. You don't do any of that. The reason being is because one is positive, one is negative. So if you literally just say carbon chloride, you're not saying mono, di, tri, because what you do, I said carbon chloride. That would have been covalent. Let's do if we say like calcium chloride. Calcium's on the left side, chlorine is on the right side. So if you say calcium chloride, that's an ionic because it's a metal and a non-metal. So what you'd have to do is look at what the positive charge of the calcium is, what the negative charge of the chlorine is, and then balance them that way. So you don't say prefix because you can just balance it. And once again, you end it in "ide." So let's name calcium or CaI2. Let's name it. So we'll call it calcium. Do you need to say monocalcium? No, we're doing ionic, and you don't need to say mono, di, tri. You don't use those for ionic. So calcium and then iodide. It's iodine, but you change the ending to I. So just calcium iodide. And you might be saying, but there's no, you didn't say di, you didn't say the two. Ionic, you don't need to say di, tri, none of that stuff. So on the flip side, if it was like this, if what we were doing is, so if it said calcium iodide, and if what it does, it gives you the name and says write the formula, you'll come up with this. And how will you come up with that? You'll look in the periodic table, you'll look at calcium, you'll see it's in the second row, so calcium has a charge of +2. And then you look at iodine, it's in group 17, so it has a charge of -1. And you'll go, okay, if calcium is +2, iodine is -1, how do these balance out? I need to have two iodines to balance out of calcium, so CaI2. So that's how you'll do it. So I think out of everything we're doing here, probably the hardest thing will be when you're given the name of an ionic, and then you need to come up with the formula. If you're given the formula and then you need to name it, that's actually for ionic, that'll be the easiest. So let's look at the lesson. So I want you to try to apply this. I want you to try to, so what you're going to do, you're going to have the names and you're going to have the formulas and you're going to match them. This assignment, probably you'll find it pretty quick. I guess the thing about this, later on, either for the review or for the next type of nomenclature lesson, I will make sure to make it a little harder, because what's going to be easy about this is that you don't have to deal with being given the name and then finding the number of each yourself. You don't have to deal with that here. So I'll make sure, because like, for example, if I give you this, if I just say like magnesium nitride and I give you a multiple choice of like Mg3N2 and then like but a Mg2N3, Mg3N, like a bunch of choices, it'll be harder because you realize I have to take this and actually balance it. And this, it's going to be kind of easy because you see magnesium and nitrogen. So we're the only ones with magnesium and nitrogen. And you're able to kind of shortcut and not balance it here. So I'll make sure in the future we have harder problems. So you at least try the harder version of this. But let's go ahead and do this. Press pause. I want you to try to do numbers 1 and 2. So do these 12 questions in total, and then press play, and we'll go through it, make sure you get it. Okay, so again, if you haven't already, pause and try this yourself. So we'll go from here, and we'll match this to whatever's over here. So dichlorine heptaoxide. Di means 2, hepta means 7. So what's one with 2 chlorines, 7 oxygens? Here we go, F. Phosphorus trichloride, that's going to be 1P, phosphorus. Tri, that's 3, chlorine is Cl. So PCl3, here we go. Diiodine pentoxide. So that's going to be diiodine, so I2. Penta means 5, so O5. Dinitrogen trioxide, N2O3. Tetraphosphorus hexaoxide. Tetra means 4. Here's 4 phosphoruses. Hexa, 6 oxygens. Disulfur dichloride. So that's going to be sulfur, and we have 2 of them. Chlorine, we have 2 of them. And then moving on to this one, magnesium nitride. Now remember, it's ionic, so it's not going to tell you how many magnesiums, how many nitrogens. If this was what you had and you had to find this part yourself, you would have to look at magnesium, see it has a charge of +2. Nitrogen has a charge of -3, so you have to balance them out. Because of the format of this, you get to skip over doing that part. And like I said, I'll make sure to give you some practice problems in the near future that will let you practice that skill. Sodium iodide, that's Na and I. Here we go. Aluminum sulfide, that's Al and S, right here. Copper chloride, that's going to be Cu and Cl. Calcium oxide, lithium chloride, LiCl. Calcium oxide, Ca and O. And there we go. So hopefully you're getting the hang of this. Hopefully this is feeling pretty easy. We are going to add some wrinkles to it in the next lesson. So make sure that you're solid on this, and then you'll be done for the day. As always, email me if you have any questions or any issues.